Hey, we've got some practice problems here. In this one, we're going to integrate from 0 to pi over 2 the tangent of x over 2 dx. So what we're going to use is we're going to use the tangent integration rule, which is the integral of the tangent of u du. And that's going to give us the natural log of the absolute value of secant u plus c. Okay, well, in this case, since we have endpoints, we won't have that plus c, but that's the idea. So what's in our u position here? Our u position has this x over 2. So kind of like a u substitution, u equals 1/2 x, that's the x over 2. So then du equals 1/2 dx. So in cleaning that up, you'd have 2 du equal to dx. So we'll make a substitution there. So that'll give us the integral. We'll still have bounds, but we'll rewrite them since they're in terms of u, of 2 tangent of u du. So I was able to replace x over 2 with u, and I'm able to replace, let me go ahead here, that's the u here. See if we can find it. And I'm going to replace the du, ooh, different color, the dx with 2 du. Okay? So in that, I have everything I need, and that means the integral would be 2 times the natural log of the secant of u plus c, but since we're evaluating this thing, we'll just go ahead and write it out. But we need to get it back to x. Remember, u was 1/2 x, so we got 2 times the natural log of the absolute value of the secant of x over 2, and that's going to be evaluated from 0 to pi over 2. So that looks like a lot of fun. So let's see. Let's let x equal pi over 2, and what would that give me? That would give me 2 times the natural log of the secant of pi over 4, and then we'll have minus, when we let x equal 0, 2 times the natural log of the secant of 0. So let's see if we can evaluate these things. So the first one here gives me 2 times the natural log of the secant of pi over 4. Okay, let's draw us a little circle here. Pi over 4 has an xy value of square root of 2 over 2. Square root of 2 over 2. So the secant there is the flip of the cosine. So that would be 2 times the natural log of, we don't really need those since it's going to be positive, of 2 square roots of 2. Then over here we'll have minus 2 times the natural log of, and the secant is 0. 0 down here has a 1, 0 for the point. And secant is the flip of the x, so that'll be 2 times the natural log of 1. Well, the natural log of 1 is 0. And then we come back over here, and I guess we can probably use our calculator to figure out what 2 times the natural log of 2 square roots of 2 is. So let's see what the calculator approximates that at. So we can easily mess this up. 2 divided by square root of 2. I'm going to take the natural log of that boy and multiply by 2. So I get approximately 0.6931. Okay. Guess there's other ways that could be written, but that's what we got here. Alright, our next problem here is we're going to integrate from pi over 2 to pi. The function 2 times the cotangent of theta over 3, d theta. So the formula we'll be using here is the integral for cotangent of u du, and that would be the natural log of sine of u plus c, but we've got endpoints, so that plus c won't really matter, but if we didn't have endpoints, it would. So let's see here. In place of our u, we have 1/3 theta, so let's write that down. U equals 1/3 theta, so du equals 1/3 d theta, so 3 du equals d theta. So we're going to replace our 1/3 theta with u, and then we're going to replace our d theta with 3 du. Okay, so it won't be a 1-to-1 conversion, but it'll work out just fine. So we're going to be in terms of u here, so we're going to integrate. We've got a 2 out here. Now there's going to be a 3 to go with it from the 3 du, but that'll be 6 cotangent of u du. So, and the way this thing works over here, that would give me the that would give me, let's just go down instead of across, and then we can come over here and finish it. That's going to give me 6 natural log of the sine of u. But remember that u was something else, so when I get back here, I'll have 6 natural log of the sine of theta over 3. And that will be evaluated from pi over 2 to pi. So let's plug it in. Let theta equal pi. So we'll have 6 times the natural log of the sine of pi over 3. Pi over 3 is that 60-degree angle. But then we'll have minus, when we plug in, let theta equal pi over 2. So that'll be 6 times the natural log of the sine of pi over 6. Pi over 2 times 1/3, so it'll be pi over 6. So now we just need to evaluate these. So let's see if I can do that. So I'm going to draw a little unit circle over here. Up here at the 60-degree angle, which we've got, the coordinate is 1/2 square root of 3 over 2, and the sign goes with the y. So this is going to give me 6 times the natural log of, I know it's going to be positive, so square root of 3 over 2. Then it'll be minus 6 times the natural log, and now I need the sign at pi over 6, which is down here, and that'll be the switching those coordinates, so the y value when we get down to pi over 6, or the 30-degree angle, will be 1/2. So we could kind of pull that 6 out front, and we could write it as the natural log of let me change the way I was going to do that. We'll pull the 6 out front, and we'll make it times the natural log of pi over 3 minus the natural log of 1/2. So when we do that, we're going to subtract 2 logs. So if we subtract 2 logs, we can turn that into division. So 6 is still on the outside, but then I'll have natural log of square root of 3 over 2 divided by, if you remember your log rules, 1/2. So that'll reduce down to just square root of 3. So the exact answer is 6 times the natural log of 3. Let's see what that is as an approximation. Just in case you carry it out or you do it a little bit different, you might want to compare. I get that is roughly 3.2958. All right, good stuff. Thank you.